Well, good evening. My name is Andy Schiefelbein. Had a long career in technology at this point. And tonight's agenda, we'll just go through that real quick. Disclaimers, an apology, and mentorship. And then we're going to go through a history of web hosting. We're going to talk about virtual hosting. We're going to do some code walkthroughs, how you might handle some user segmentation because we're doing this in native Go, and a little bit on load balancing. So this is informal, ask questions, shout insults, whatever you want to do, except within the code of conduct. You know, they have to be nice. So let's see, the introduction / apology. So got my name over. I was supposed to do this talk last month, but some of you may know I am a low brass musician, and I was playing in a community band in the summer to keep my chops up. And the conductor waddles over and says, I want you to play tuba on the next two concerts. And I'm a bass trombonist. I have a tuba, but I gave the tuba to a kid that I sit next to in the big band that I'm in. So he has my tuba now. And I go, well, I don't have a tuba. And he goes, don't worry, I'll get you one. So he gave me a tuba to play. And I enjoyed it so much that I completely forgot that I was supposed to do the presentation last month. So I didn't get it finished in time. So it got pushed to this month. So that is my apology. But the other part of that is, it leads into the mentorship stuff that I wanted to talk a little bit. And given the events of the past weekend, this is kind of an unusual thing because everything I'm going to talk about is based on knowledge that I gained 25 years ago from my mentor. At the company that I work for, I forgot the disclaimer. I'm not here representing a company, I'm not here representing a library. I'm here because I think Go is the better way. And I want people to feel free to use it. And if I can help do that, that's why I'm here. And that's sort of the other part of the mentorship is that the virtual hosting, the web hosting, and I'm going to show a little bit of Apache and stuff like that, that all came from one man, Mark, who has been retired for 10 years. And there is a world in which I exit this industry in the next 8. It's possible, unlikely, but it's possible. And then all of that knowledge disappears unless I hand it on. So that's kind of what I'm trying to do here. So part of the mentorship is just showing people how to do stuff. And part of the mentorship is representing a good way to do stuff. And I've been on the receiving side of both of those, and I'm trying to give them back out. Like I mentioned, Mark, the guy that I learned all the web hosting stuff for, one of the best technologists I've ever worked with. But on the other side of that, just demonstrating how to be a good anything, I would talk about a guy by the name of Jim Sawyer. And I know you guys wouldn't know that name, but you've heard him. You've heard him play the most famous B flat of all time at the beginning of Star Wars. He was a studio musician in LA, and he lived in St. Louis for a while, and I played in an orchestra with him. And he never gave me direct feedback about how I played, but if you listen to him, every time he played, it was a master class on how to articulate how to play. And so that's a different way of mentorship, but both are valid. So if we're out there giving goodwill and being good mentors to everybody else who's in this industry, and there's a lot of reasons why we need to do that, something to think about. The other thing is I plan on selling sweet corn out of the back of a Chevy C50 somewhere on Route 3 in Illinois at some point. And in order to do that, I've been reading up a lot on market gardening. And this book has a lot of good points that are valid outside of that as well, which is failure to plan is failure. Because what happens when your barn burns down or your equipment stops working, or you're no longer able to physically do that. When you're running a business, you have to plan for those things. And if you don't plan for those things, then whoever comes behind you has problems. So that's my little spiel. And I think about it a lot because I'm last of Mohicans where I'm at. Nobody's coming up behind me. I've talked to my boss about getting interns, but the zip code I'm in is not the preferred one for the company I work for anymore. So what is virtual hosting? It's pretty much the same as web hosting, except we're handling multiple DNSs out of the same backend. So you have a singular web service, and you can handle different DNS names. In this case, the example tonight, and all of this is in GitHub, by the way, we have localhost grow with STL Go local dev and grow with STL Go admin. I wasn't very imaginative on the demos, but we'll get there in a bit. So there's going to be a singular binary on the back end hosting all of these things. And we're going to demonstrate how it was done in the old school way, and we're going to talk about how it's done with Go. So, history of web hosting. I started with Apache HTTPD probably mid-90s. And I think it came out in 95. That was the big static web thing if you were back then. Nginx came in 2003 or 4. I don't really remember. I've never done Nginx, but it's basically, you send a web request, it locates the file on the disk, hands it back up, and then bingo bango. It's rendered in the browser. So we have the proto web services, which was CGI bin, which allowed you to execute stuff. And a lot of that was the 3 Ps, what I called it, Perl, Python, and PHP. My mentor used Perl. I was never a fan. We eventually converted to Python. And in between those two, we used PHP. But, all 3 of those are, I wouldn't do it for web hosting anymore. But you can. So because we're talking about Apache HTTPD, let's do a little bit of a demo here. So I left some breadcrumbs out here, and the GitHub, this is live. This is the STL Go, Grow with STL Go GitHub, which is out there for this little learning series that we're doing. How to compile Apache from source. Has anybody ever done that? Besides Paul? If you haven't, this is a dying art. And this is what I'm talking about, handing on stuff that I learned. I don't like the binary distribution that comes with Ubuntu, and my laptop that I'm doing a presentation on is Ubuntu 2204. And the binary distribution has this weird spread out configurations. I don't like it because that's not what I'm used to. I'm used to compiling it and having it the old school way. And so these are instructions on how to compile it along with all of the other stuff, because you have zlib for compression, OpenSSL, Perl regular expressions, and I don't even know if you need that anymore. That's probably just a legacy of Mark's stuff that I'm still doing. Apache portable runtimes, and then the HTTPD themselves. It also goes to the configurations here and a few various other odds and ends about how you would set this up. I didn't put a lot of verbiage around there, but if you're interested in doing that, here's some breadcrumbs. But if we take a look at, I have a mouse. Why am I not using the mouse? Okay, we have here, come on now. There we go. A web root. And this web root has a couple of different things. It has a log file. It has the CGI bin directory, which is a script alias. And then it has the static web files. So the static web files are in the web root. So, and that is just an index.html. We take a look at it. It's real basic. It's going to have an XML HTTP request. It's going to send that request to the CGI bin directory to get that program to run, and it's going to render the output to a basic division on this. So I have Apache running on 11.4.4.3, and this is going straight to the CGI bin directory, and it's just going to output JSON data, which is, pretty typical nowadays. Way back then, you would do more a different MIME type because JSON wasn't real prevalent. It would be more text HTML, stuff like that. It was not as nice. But this is going through the web page, which did the HTML request, the XML HTTP request to the example, and then rendered it to the division. So this is going through Apache HTTPD, and that is a VHost in the system. So if we take a look at how that is configured, we have 3 VHosts being served right now. We have the default, which was the one we just saw. We have the 2 others, which are the Grow with STL Go admin and the Grow with STL Go, just the regular one. And each one of those we have some interesting stuff in there. We'll just take a quick look at one of them because you have to define what port you're running on, what server you're listening to, the SSL stuff, your web routes, your script alias. And a while ago we used to do proxy passing where you have a specific thing inside your application, for example, CGI bin, that you need to route to a backend. And you also had mod balancer, which was a proto HA proxy or a proto load balancer in Apache. This all existed well before a lot of the tools did for all of this. But if we take a look at the others, the other virtual hosts for this guy, put this on 11.443, which is, that is the one of the two actual vanity URLs that we're using tonight. But if I try to log into this, I'm going to try to log in as user and give it a random password. It doesn't actually use WebSockets because the backend on this is WebSockets, and I spent a while trying to get a proxy pass working for WebSockets with Apache. I could never get it to work, and this is how technology sort of goes to die. And one of the reasons why I would, if I was doing this as a member of a company or employee, I would probably ditch Apache and go to something else because I couldn't get the proxy pass to get this website working. So that's kind of the history of, basic web hosting, at least a quick version of it. And if we talk a little bit about what happens on top of that, then we went through our web services. We had SOAP, which kind of sucked. We had REST, which didn't suck as much, but still has some limitations. And then we have WebSockets, which I keep beating on because I like WebSockets more than REST. But I have a longer written out version of this out on the GitHub if you want to look at more verbiage around that. But the web servers we would use would mostly reroute to a backend web service to do database stuff and render things, and you would see the web pages. But then we have Go. We can do the static web in Go. We can do the vanity URLs in Go. So why do we need Apache? Well, we don't. So what I have is a config file, and we can look at the web config structure and the JSON first, and then go look at the code behind it. We have this web service, and we have the VHosts in the web service. So we're listening on 3 VHosts at this point. All 3 will be responded to on that port, and how you respond to those VHosts is the different actions that happen behind it change with each one of them. So the configuration file itself is controlled by configs, and we have the web service in here, and then it's just a map of web routes, essentially. But the server listening on a specific host and port. And in this case, in order to handle it, it's basically, if you we're just doing this for a regular one, it would just be listen on slash and pass your handlers. But here we're using the vhost as our handle func, and then we pass it back to a HTTP request. So that HTTP request is then doing stuff specific to that vanity URL. In some cases, we have 2 different web routes out here. We have our regular one, and then we have the admin one, and these are clones of each other. But if you wanted to share stuff between us, you could add special rules to it so that you could have your node modules, for example, set out to the side of both of these and handle that for both of them instead of having to have them inside each web route. In this case, I was lazy. But it's just a basic web service at that point, except you're handling a vanity URL. So if we take a look at these, and these are on port 10443, we have this one, which is the regular one, and then we have the admin one. And this basic web service I went over in a previous version of this thing in the Learning Go series that we did here. So if you're interested in that, there's probably some more information on our previous postings on this one. But we have 2 users that it created, and these are the hashed up passwords. Wow, and if I stop remembering that Control-C will exit out in Linux and actually use Control-Shift-C, it would be good. All right, Control-Shift-C, even better. All right, but we have 2 here, vanity URLs. This is the regular one, so we're going to log in with user. And we should be able to get in here, and we're going to buy a couple of seed packets. Okay, done. Great, wonderful. Now we're going to go over to the admin page, and the user should not be able to log in here because, yep, we gotta, if we take a look at the console, closed out the WebSocket, said get lost. If we look at the logs over here, closing WebSocket, grow with STL go, nope, user not authorized for this vanity host, or vanity URLs, which is correct, and that's what it's supposed to be. So we have an admin that can log into both, and then you would set passwords in the admin. So if we log into admin, and I use Control-Shift-C this time, you should be able to go into here, and then actually see the admin page, which looks a lot like the other one, because again, I was lazy. But you should be able to go in here and set which vanity URL an individual user can access. And same with creating new users, you can set their level of access. So how do you control that? Everything's coming through the same thing. So we have an authorization, for lack of a better word, class. But if you come through here and you look at this, it's the validate the API user. The API user has to have an entry in that vhost for that API user to allow it in there. So if it doesn't, reject it. So that's kind of how you stratify virtual hosts inside of the code base, and you handle different requests based on the vhost coming through. So that's, again, kind of a overgeneralization of virtual hosting, but in Go, it's fantastically easy. I've done this in Python, I've done this in Java with Jetty, and it is not easy in either one of those. This, you just give it the vanity URL at the time you're doing your web hosting, done. I mean, why would I choose anything else? But you're tied to a specific host and port at that point. Now, if we're talking typical web hosting, you have 80 and 443. 80 is static web, and if we go back to, nope. Come on now, let's get out of here. There we go. So we're going to go back to Apache for a bit here, and that's on 1180. And if we move this to HTTP, you'll see some of the old tricks that we used to pull. So this is straight HTTP, and it's going to rewrite to HTTPS. So you see now you're on 11.443. That's the type of stuff you can't do as easily, because then you would have to run your service on 2 ports and do redirects. That's why we do load balancing, for multiple reasons. And I have HA proxy on this machine, and again, I have docs out here for HA proxy if you're not used to it. What is HA proxy? Well, in a real world, I love this diagram, by the way. In the real world, you use a floating IP between a couple of active load balancers. When one goes down, it's routing to multiple backends. This is how I've used HA proxy if you're using AWS. This is how AWS does it. They just don't call it HA proxy. Same with Azure. But unless you're using an F5 load balancer or Akamai, this is typically what we do. So we can, at this point, look at HA proxy on the system. And we'll take a look at the config here. And again, we have our vanity URLs that are going to listen on this, and they're just going to proxy pass to the Go backend. But if we play the what if game here and use your imagination a little bit, you could have those backends spread out across and spray traffic. So that's how you do a clustered version of this application, because there should be no single point of failure. in an ideal world. But then you can also do the tricks that we're doing with Apache, which is, and I have this running on the standard ports on the box, which is 80 and 443. So we're going to go back to straight HTTP on this, and it's going to redirect to HTTPS 443. And, whoops, I want to go back to this guy, and I don't want, we could use the admin password, that's fine. And the wonderful thing about HAProxy, it proxies WebSockets without a problem. And again, that's why I no longer use Apache. Well, one of the reasons. But that is a really quick demonstration on HAProxy and everything else. Quicker than I thought it would be, actually. So, questions? I guess, thank you and good night.
So, we did this, what versions of HTTP does Go support?
I'm sorry, could you repeat that, please?
Is it like, one or two?
Oh, it does all of them, country and Western. But yeah, it's, I think if we look at the code here, the server itself, we don't specify an HTTP version. Now, HTTP version 2 is typically, I think, is just HTTPS protocol. And I don't start Go on anything other than HTTPS. There's no reason for us to really be doing anything other than encrypted channel at this point for anything. But specific to version on that, I'm running TLS 1.3, which is the latest because 1.2 was deprecated last year or early this year, I think. And they're going to start pounding on people about doing 1.3. And that means also your certificates need to be probably a 2048 key, if not a 4096 key. So that starts talking about SSL spec, and I could blather on about that for a while if you'd like to. But speaking of SSL, since we're here, we might as well talk about it. We take a look at the cryptography stuff here, and I did a demonstration on this, I think, the previous time here. This is an X509 certificate signing thing. So it goes through here. It has the vanity URLs and the extension, which is the subject alternative name extension for the X509 certificates. So this certificate is valid for localhost and the two vanity URLs I'm showing tonight. But so if we take a look at the key creation up here, where is that? Generate private key. Key size, what is the key size? This is probably a 4096. Yeah, it's a 4096 key. So that's what I mean by a key size. And that's just, it's a cryptographic key of 4096K, or 4K essentially. And it's, if you ever look in the Diffie-Hellman key exchange and stuff like that, where it's calculating two large primes, and when they combine, they create a symmetrical key, and they hand them back and forth. And that's how it happens. And the larger the key, the harder it is to calculate. And that's why us as casual observers can't break into that channel, because if you had that symmetrical key, you could just go, okay, thank you for the traffic. But that's kind of how that works. Again, I could blather on about this for a while. And since we're here, again, why not talk about it a little bit? You see the passwords, and I talked about this last time too. Passwords are obfuscated on disk. These passwords are hashed on top of it. So even if you decrypted it, it's going to be a hash of a password. You're never going to log in. So you don't want to leak stuff in your configuration files, and you don't want to check these into Git. Somebody had taken my code, and this would have been, speaking of mentorship, one of the junior developers I had left the company. And he liked my code so much, he copied down the repos and took them with him, and then put them on GitHub. And there was configuration files with clear text passwords on GitHub. And somebody saw them and tried the URLs with the clear text passwords and the IDs, and then tried to get a bug bounty from the company that says, you have code sitting out here. And I had to call the guy up, and I'm like, what the F are you doing with my code on a public cloud repository, because it had my user ID associated with it, which is not my name. So I got contacted saying, you've got code on the public. I'm like, no, I don't. And it was the junior developer I had. So this is, after that, every configuration I have now is obfuscated by default in case they happen to leak into the wild. So, but.
I'm kind of curious though, have you done anything with, I mean, it's kind of a little tangent, but like with gRPC? Doing any gRPC servers?
I have not. Could you, I don't even know what gRPC is, if you.
It's basically protobuf
Okay.
over the wire. I mean, it's, yeah. No, I was just kind of curious because that's something that might be a good topic. Yeah, CNCF ambassador again. gRPC is a CNCF project.
GCP loves it too.
Yes, yeah. But yeah, it's basically just compression and in being able to do remote procedure calls.
Oh, okay.
Essentially, and but yeah, all the communication is protobufs.
So is it like gzip or zlib or something like that, compression over the wire? Or?
I mean, it's a little bit. It's not like not quite like SOAP or I have WSDLs and stuff like that. But I mean, it's you can you define your services with protobuf, if I'm not mistaken, and that's. And I'm probably talking out my backside because I have not written anything with gRPC, but I saw it on TV once. Yeah, no, I mean it's. I don't know. I totally lost track of where I was headed with that one, but no, I was just kind of curious to be able to contrast maybe with some of this stuff too, since we're on kind of like a hosting type thing.
It'd be interesting to try that, because Apache used to have mod deflate, which was run out of zlib, and I'm highlighting the configuration for that right now. I never, and for a while there when I was in Java, I would use gzip on the output. So I would have the headers, gzip the JSON, and then stick it on the wire, and then on the other side you'd have to uncompress it. Zlib you could uncompress in the browser, but with natively. With gzip you couldn't do that natively in a browser, so it would have to go to another client to do it. So I've not messed with that. It'd be an interesting thing to mess with.
Yeah, and I mean it's at the protocol too, but it does depend on, from what I understand, it does depend on HTTP too. So for that bi-directional stuff. We did back during the COVID times, we do have a video on the channel where John Corey, he's the organizer for the Atlanta Go meetup group. He actually did a presentation for us, virtually of course, but yeah. So that's one I probably should revisit because I kind of want to play around with it a little bit more. A lot of things in Kubernetes land will use that too. So like Linkerd, another CNCF project. That's bizarre. There's so many, but yeah, it uses a lot of that for internal communication between its pods and things like that. So that's one that probably put on the schedule for upcoming talk. Probably not by myself. So if anybody else is a gRPC expert or wants to become one, this is your opportunity.
I think gRPC is great if you have different languages. So if your environment is made up of multiple, and you want high performance.
Yeah, because I know you can use the protobufs to generate the, basically your deserializers and serializers and all that. So, yeah, kind of like what you can do with some of the Swagger UI things.
So I had a question. You mentioned no Nginx, no Apache, right?
Yes.
That's your setup.
That's my setup. No Nginx, no Apache. Backend's native Go. You can go straight to the host and port on that, or run it through an HA proxy. And what I'm doing at work right now is I have a global load balancer, which is run not by me. I think they have an F5 appliance, if you're familiar with them. And then they're not even re-encrypting, they're just passing through the connection. And so I can cluster my backend. Without Apache, I don't need to serve static HTML with anything else, nothing else to care and feed. So all the one binary on a couple different servers through a load balancer, and I'm golden. The deployment is easy as can be because it's a binary, targ zip it on the box, done. You know. Well, that and tell the load balancers, hey, I need to add this server, or it comes down automatically, and you can do a rolling deployment that way too.
So what is stopping everyone else to get off Nginx and
Oh,
it does add more overhead to manage a certificate.
so to repeat the question, and I forgot to do this earlier, to repeat the question for those of you on the web, the question is, what's stopping everybody from getting off of Nginx and Apache and just going straight load balancer? And I'm gonna probably say it's the same thing as anything else. It's inertia. And if you've worked with some of the people in the industry, you'll know that database people don't understand how to manipulate data unless it's inserted into a table and then selected from. Or if you're using business people, they don't understand why you don't want to put periods in the name of your JSON key. You know, stuff like that. So two things is ignorance and inertia. Ignorance can be fixed. We can teach people how the better way is. Inertia, that's harder. It's working now, why would I want to change? I have to write something else to do that. It's not tested. Prove to me that it's better. You know, there's a lot of that. And I think as good stewards of technology, we can navigate that. And I was talking to Paul earlier. I'm kind of in an odd position right now where I'm doing boutique development. So I have a business guy that's 1,000 miles away from me, and he says, I need a problem solved. And I go, okay. And I go, this is my solution. He goes, great. Nobody's questioning me. Now, the other teams they're going to have architects, and I could do a whole night about who architects who don't code are the death of projects, because I've been on a lot of those with architects who don't code. They knew what they knew 5 years ago when they stopped. And back in the day it was Apache, Oracle, and probably like a JBoss or embedded Tomcat or something like that. And that's what we're using. Why would we want to do anything different? So not a great answer, but it's an answer. I think people with an open mind who are accepting that not everything we do is perfect, and that our time here is finite, and that other people have interests that might be a good itch to scratch, put a different sort of pressure on a project than maybe others who have a different approach.
I ask is every cloud, public cloud environment, they all have this recommended architecture, right? So that's why this would save everyone a lot of
Absolutely.
resources.
Yeah, it's all, software as a service. Why would I want to do this? Because I can go click a button and, okay, Apache serves it. Now I just have to tie my GitHub repository so it drops my static HTML here. And then I have to wire up my proxy passes to do this now and all that other stuff. It's a lot of configuration for complex environments. Like back in the days with the WebSphere and JBoss and WebLogic, those got really, really complicated. And thankfully I stopped doing that about 2014. But that's when they sold hosting to IBM, and I was no longer part of hosting then, so. But that was the last time I did that. And anyway.
All right.
Huh?
Well, thank you.
Thank you.